Hi, this is Miss Oliva, and I'm going to go through 2.2, which is the introduction to polynomial functions. So these will be functions that typically have degrees higher than 2, because we know 2, if the degree is 2, it's a quadratic, and that's a parabola, and we've already done a lot with those. So now we're looking at higher degree functions. So first thing we're going to talk about is the end behavior. How can you tell just by looking at an equation, not a graph, what the end behavior is? So here's all you need to look at to decide. If you know these 4 situations, then you can tell me the end behavior for any type of higher power graph. So if the number in front, which we know is our A, if A is positive and the power is some kind of even, so x squared, x to the 4th, x to the 6th, x to the 8th, it's going to behave just like the parabolas we've been dealing with, right? When they are positive, they go like this, which means on the left, that's what end behavior is, this and this. It doesn't care what's happening in the middle. What's happening on the way left, what's happening on the way right. So this is how they write it. As x goes to negative infinity, which basically just means left. As we go to the left, where x's go to negative infinity, what is happening with the y value? So is it going up or down? So if it's going up, you say it's going to positive infinity. So as x goes to positive infinity, which basically just means as we look to the right, because that's where the x's get bigger and bigger and bigger, what is happening with the y? It's going up again. So as we look to the left, the y's are going up. As we look to the right, y's are going up. So this would be the same for even a way more complicated equation if the front number is positive and the highest exponent is even. So not this one. So the next one will be similar to this because it's saying you have a negative in front and an even integer. So isn't that what's happening here? So as a reference, you can kind of compare it to a negative x squared graph where to the left it's going down and to the right it's going down. So how do we say that? As x goes to negative infinity, which means to the left, the y's are going down. So they're going to negative infinity. In this case, as we go to the right, same thing. So basically, the easier way to think of this is the case where we go up and up. This is the case where we go down and down. So for even equations, meaning the highest power is an even number, it should either be up, up, or down, down. Should never be one of each. If it's one of each, that would mean there should be an odd exponent. So positive looks like this, which is similar to the y equals x cubed. So you should be a little familiar with this one. So as x goes to negative infinity to the left, do you see that the graph goes down? So we would say that. And as x goes to infinity, which basically just means to the right, the graph is going up. So this time they aren't the same. So if you have a positive x to an odd power, it's going to go down to the left and up to the right. And then negative just does the opposite, right? It just flips it. So as we look to the left, it goes up this time. As we look to the right, it goes down. So to the left, up, to the right, down. So if you can memorize these 4, and I know looking at this looks like a lot, but really if you can just memorize that the even functions we've been dealing with a lot, the positive ones look like this, so that means up and up. The negative looks like this, so down and down. And then the odds are either this way if it's a positive odd or the opposite. So if I'm looking at number 1 and all they want to know is what is the end behavior? All I really care about is that 4 is the highest integer exponent, and there's a negative out front. So this is a negative x to an even power, which means either up, up, or down, down. But because of the negative, it is down, down. So I would say to the left and to the right, we're headed to negative infinity. Okay, looking at the next one. If you want to pause here and try these, go for it. But the next one, I'm looking at a 7 as the highest power and a positive 8 out front. So positive x to the odd, I know looks like this. So to the left, it's going down, and to the right, it's going up. Now for the next two, be careful, because a lot of people would say that the next one, the highest power is a 3. But that's not true, because this is not written in standard form like these are. This, you have to think about that in reality, these things are getting multiplied to each other. So if I have some kind of x to the third here, but it's being multiplied by an x over here, my highest power is really 4. You can multiply this all out if you want to see, but it's would take you a long time. So if you just can kind of say, well, I have an x to the 3 times another x, so that would make it x to the 4th, you're good. And then your answer is going to be whatever is way out here, right? So I have a negative x to an even power. So that is down, down. So maybe try the next one, but don't forget to include all of the x's that are being multiplied. So I have x to the 4th here. This stuff is being raised to the 3rd, and this is basically an x to the 1. So 4 plus 3 plus 1, I really have an 8 with a 2 out front. So even, but positive this time. So to the left and to the right, it's going up. Okay, so that was end behavior. Now we have a new theorem. It's called the intermediate value theorem. It sounds super fancy, but it's really not that complicated once you get the hang of it. So here's how it's written. Let f be a polynomial function for a less than b. If f of a and f of b have opposite signs, then f has at least one 0 on the interval a to b. So what in the world does all that mean? Well, it's just saying, let's say you have an a and a b, and let's call a the x on the left and b on the right. It doesn't have to be negative and positive, just one's here and one's further to the right. They're saying if f of a, which just means the y value here, has a different sign than f of b, which is the y value here, which means if that one's positive, this one's negative, and it's a polynomial, which means all these points are connected, there has to be a 0. There has to be an x-intercept in between. And yeah, that makes sense. If we go from a positive y value to a negative y value, I must be crossing the x-axis at some point, which means there definitely is a 0 in between. That's all it's saying. So instead of having to graph all of these again, if I'm trying to find out, is there a 0 between 1 and 2? That's like my A and that's like my B. I just need to find f of the A, which is f of 1, f of the B, which is f of 2, and see if this type of thing happens, meaning one of them's positive and one of them's negative. So how do we do that? Well, you just plug it in, right? This is like my x value. I'm trying to find the y value. So 1 to the 4th plus 6 times 1 to the 3rd minus 26 times 1 plus 15. Oops, I'm in my A and B way. What do I get? 1 to the 4th is not 4, so be careful. It's just 1. So I have 1. 1 to the 3rd again is 1 times 6 is 6. So right now I have 1 plus 6 minus 26 and then plus 15. I get -4. Okay. So my answer to is there a 0 between 1 and 2 is only going to be yes if I get a positive answer for this next one, because they need to be different signs. So let's find out. 2 to the 4th plus 6 times 2 to the 3rd minus 26 times 2 plus 15. 2 to the 4th is 16. 2 to the 3rd is 8. 8 times 6 is 48. 52 and 15. So 16 plus 48 minus 52 plus 15. Positive 27. So show that there's an interval, that there is a 0 between this interval. That's what shows it. So yes, there is a 0 between, we don't know exactly where, but definitely between 1 and 2. Okay? How about if we're given this new equation and we want to determine if f has a 0 on the interval -4 to 0. So this time they're not setting it up for me, but I know to answer that question, I need to find this and I need to find this. So plugging -4 into there is going to be a little tricky. I just need to make sure I do the correct order of operations. So I'm going to maybe move this down because the 0 is going to be a lot easier. All right, so -4 to the 3rd is going to be a negative times 4 is -256. -4 to the 2nd will be positive 16. So 16 times 28 is 448. A negative times a negative is going to be positive 100 and then minus 175. So -256 plus 448 plus 100 minus 175. I get positive 115. I mean, sorry, 117. Okay, that tells me nothing yet. I need to see now what happens with f of 0. So zeros are lovely because you plug it in, this all becomes 0, this all becomes 0, this all becomes 0. So we really just have our negative 175. So positive and negative means there must be a 0 in between. So yes, there is a 0 in between. Well, now they want us to find it. So this can be very tricky, but luckily in this section, we haven't learned some of the trickier ways to find zeros. So we will most likely be able to factor these, even though it looks like there's a lot going on here. So remember, when you have 4 terms, you can try factoring with grouping, meaning just look at these two and take out as much as you can. Then look at these 2 terms and take out as much as you can, and then see if something matches and you can go further. So we can take a 4 and an x squared out of these 2, right? That would leave me with x plus 7. I could take a 25 out of these 2, but I can already see that would leave me with a negative x in the parentheses, which is kind of weird. So I'm going to just take out a negative with it. So if I take out a negative 25, I'd be left with an x plus 7. When you're doing grouping, this is what you hope to see, that the 2 parentheses match, because then you can go a step further and take that out and say, if I took the x plus 7 out of both things, what would I have left? 4x squared minus 25. But then don't forget, if you have a square minus another square, you can do difference of squares. So what would get me to here? 2x times 2x. What would get me to 25? 5 and 5. You will always have one positive and one negative when you're factoring a difference of squares. So here are my factors. So what are my zeros? Well, I can set each thing equal to 0 and solve, which would give me a -7 here. Here, I guess I'll show it just in case you need it. If I set this one equal to 0, I would subtract the 5 and divide by 2. I would end up with this fraction. And then for the last one, if I did the same, I would add 5 this time and divide by 2. So I would get a +5/2. So we have 3 zeros. But what was it asking? Find a 0 of f on this interval. So -7 is not between -4 and 0. So we don't want that one. +5/2 is not between -4 and 0. So hopefully this one is, which it is, because -5/2 is the same as -2.5. So this is the only one that is on the interval. Okay, just by looking at a graph, how do you tell if it is a polynomial function? Well, it needs to be smooth and it needs to be continuous. So first, what does continuous mean? It means that you can draw the whole thing without ever picking up your pencil or pen. What does smooth mean? That there are no sharp points. So this and this are sharp. So this one is continuous, but it is not smooth. So it is not a polynomial function. This one has no sharp points, but do you see that it's not continuous because I would have to pick up my pencil in the middle? So this one is also a no because of this. So 3 is the only one of these so far that is a yes. It is a polynomial function because it's smooth, because this is not a sharp point, it's just a rounded edge, and it's continuous. So how do we get the minimum degree of the polynomial? Well, it's always one more than how many terms you have. So here it turned, and here it turned. So if it turned 3 times, then the minimum degree is 4. Why is it the minimum degree? Because there could be some imaginary zeros, which we wouldn't see on the graph like this. So there could be more. The leading coefficient, they just want to know, is the leading coefficient of my equation, even though we don't know the equation, is it positive or negative? Well, if you see it going down on both sides, doesn't it have to be negative? And the degree has to be even because of our end behavior rules we went over. And then the approximate real zeros with even multiplicity. That means that they happen like twice or 4 times. So how do you tell? Well, this is a 0, this is a 0, and this is a 0. Do you see how this one just kind of bounces off that point where this one goes right through and this one goes right through? If it bounces like that, there's an even number, meaning 1, 2, 3. This is -4. It means we have a 0 of -4 and another 0 of -4, or even more. There's an even amount of them, where if it goes straight through, there's an odd amount. So what is the approximate real zero with an even multiplicity? Just that one point. So -4. And which of these zeros seems to have an odd multiplicity, meaning they just happen once, maybe 3 times, maybe 5 times? -2 and +1. Okay, the function g of x, which is this, touches but does not cross the x-axis at 5/2, 0. So what they're basically asking is, at 5/2, does it go straight through or does it bounce there? Okay, that's what they mean by touches and does not cross. So what are our zeros according to up here? Do you see that we have a 0 of -4? But that only happens one time. So that means at -4, it's going to go straight through. But then here, if we set this equal to 0 and solve, we also have a 0 at 5/2, and there are 4 of those. That's what that 4 means, that there are 4 of those zeros. So wouldn't that mean that at 5/2, which is 2.5, it would bounce at some point? So this would be something where we go straight through here, but at 5/2, we bounce. So true, at 5/2, it touches but does not cross the axis. Okay, looking at this one, let's talk about the end behavior. It's even and it's negative, so it's going to look something like this, right? They're asking it in a much simpler way here, which is nice. So all you have to say here is end behavior is down to the left and down to the right. Now they want the y-intercept. So they want us to plug in 0 for the x's and solve, which would just give us -3. And now they want the zeros, which means plug in 0 for the y. Because remember, zeros is the same thing as x-intercepts. So again, in this unit, hopefully we can factor. I don't like having a negative in the front, so I always take that out first carefully because that will change each sign. And then see if I can factor this. Are there two numbers that multiply to 3 but give me -4? Yes. -3 and -1. So my zeros would be 3 and 1. Oh, I made a mistake. Hold on. Sorry. I forgot that it was next to the 4th. So you do factor this the same way, but you just need to make sure that you have an x squared on both of these. Okay, I knew I made a mistake because I only had 2 answers when I really should have 4 answers, right? So let me say that again. I took out my negative first, which changed the signs of everything. But then, since I had an x to the 4th, an x squared, and a constant, I can factor this the normal way, but just instead of an x and an x, I need an x squared and an x squared. So now I'm not done. So this negative out front I can ignore since it doesn't have an x with it. But I need to take this and set it equal to 0 and solve, and this. So here I would add 3. Then I take the square root of both sides, which gives me a positive and a negative answer. And same here. I add the 1, but then I take the square root of both sides. Square root of 1 is 1. So this is 2 totally different answers. So I have the square root of 3 as a 0, negative square root of 3, 1, and -1. Those are my zeros. So now they want me to sketch it. So I'm going to use the points that I have found so far and plot those first. So 0, -3 is my y-intercept. I can definitely plug in that or plot it. 1 and -1 are both x-intercepts, but now I also have these square root of 3s. So in my calculator, I put it to get an estimate that it's about 1.732. So 1.7 is about here and here. And now, where do I start? Do I come down or do I go up? Well, if we already know the end behavior is that we go down and down, I can start by that, and then go through each one of these because none of them were a double root. So it should look something like that. And that is it for 2.2. If you have any more questions, please.